Hi students, this is Mr. Eckert. We're going to go through Target H10, which says that you should be able to accurately apply and interpret something called the chi-square test to results of real-world genetic crosses. So what in the world is a chi-square test? You can see on the screen here this equation, and that's the chi-square test. It's a math equation. It looks pretty complicated, especially if you maybe haven't had algebra yet, but we're going to go through it step by step, and you'll see it's a lot easier than it looks. So why do we even worry about it? Well, using the chi-square test is something that is going to be useful whenever you do an experiment or an investigation and your results that you get, your observed results, are different from your expected results. So when that happens, one might ask the question, well, is that just due to random chance, or is there something else at work that might be skewing your data? So let's look at a simple example. You remember you did activities where you flipped coins and you expected to get a certain number of heads based on how many times you flipped it. I believe you did an activity where you flipped it 20 times, 30 times, and 50 times. Obviously you expect to get half the number of heads. So let's say we flip it 100 times. We would expect to get 50 heads and 50 tails, but let's say you actually get 62 heads and 38 tails. So is that just due to random chance, or is there some other factor at work? Maybe I'm applying more force to the coin on some of the flips than on others. So we can use the chi-square test to find out. So first, what are the different parts to this equation? Well, we have this part right here, which you can see is x squared to the sub c, and that of course is the chi-square. Then we've got this O sub I. Well, that stands for the observed data that we're actually going to collect during the investigation. Then you've got two E sub i's, and I'll bet you can probably already guess what that's going to stand for. Is O, if O is for the observed data, then the E is the expected data, the expected values that we expect to get from doing the experiment or investigation. So we obviously can figure those out before we even start. This symbol that looks kind of like a crazy E actually just means sum. So that means we're just going to add up these values that we're collecting during the chi-square test. Whoops, went back. We need to go back a page. Alright, so when we do a chi-square test, there's always something called a null hypothesis. This is a little bit different from what you're normally used to hearing in terms of a hypothesis. So usually you think of a hypothesis being an educated guess of what's going to happen. But the null hypothesis is actually the same in every time you do a chi-square test. And the null hypothesis is that you're going to expect there is not going to be any significant difference between your observed and expected values for the experiment. In other words, another way to say that is that you expect that the differences between your observed and expected values just to be due to random chance. So we're going to use this chart to help us interpret the values that we get from our chi-square test. A couple terms you're going to need to know on this chart. One is the degrees of freedom, which you can see in this first column here, and it goes from 1 to 10. And then the other is the critical value. So degrees of freedom is defined as the number of scores or outcomes that are free to vary. Now that probably doesn't make any sense to you at all. But in most situations it says the degrees of freedom are equal to the number of outcomes minus 1. So let's think about our coin example. There's two outcomes, right? You can get heads or tails. So we do, it's always 1 minus, or I'm sorry, the number of outcomes minus 1. That gives you the degrees of freedom. So in this case we would have 1 degree of freedom. If you are doing, let's say, a Punnett square cross between two heterozygous individuals, and let's say tall is dominant over short, you know you're going to get 3 possible outcomes. So 3 minus 1 in that instance, you would use 2 degrees of freedom. So just whatever you're doing, you're looking at the number of outcomes, subtracting 1 from it, that gives you the degrees of freedom. The critical value that we will always use always in class is the 0.05 column. So that means if our number falls, our chi-square value falls, it says in that column, but it can actually be less than that number. Then we can be 95% sure that we can accept our null hypothesis. In other words, that the differences between our expected values and our observed values was just due to random chance. Okay, so that is our null hypothesis. There's no statistical difference between our observed and expected values. So we got 62 heads and 38 tails. We expected to get 50-50. So was that just due to chance? So our critical value, since we are using 1 degree of freedom, our critical value is 3.841. Okay, so if we get a value higher than that, then we're going to reject our null hypothesis. In other words, we're going to say, well, there was something else going on other than random chance if I get a chi-square value higher than my critical value. So any value equal to that critical value or lower, then we're going to accept our null hypothesis. Then we're going to say, yeah, the difference between those was really just due to chance. So let's use the chi-square test. We expect to get 50 heads and 50 tails. We got 62 heads and 38 tails. So the first thing we're going to do is take the difference between those. As you can see, it's the observed minus the expected, and then we have to square those values. So 62 minus 50 squared divided by the expected. Remember, the expected was 50. And we're summing those. The symbol here, remember, means plus, so we're summing the same for the tails. The observed, 38, minus the expected, 50. We're going to square that. Now, of course, that's going to be a negative number, but you know that anytime you square a negative number, you always get a positive. So you'll never have negative values when you do this chi-square test. And then we're going to divide by the expected again, which is 50. Okay, so we have to add those two numbers together. All right, 62 minus 50 is 12. 12 squared is 144, and 144 divided by 50 is 2.8. 38 minus 50 is negative 12. Obviously, that's going to be the same value when we square it. It's going to be 144. When we divide by 50, that's 2.88 again. We have to add those two numbers together. So 2.88 plus 2.88 is 5.76. And probably should have used a different color there. It's kind of hard to see that. All right, 5.76 is above our critical value of 3.841. So I'm rejecting my null hypothesis. And the difference between the observed and the expected values was due to some other variable other than chance. So again, maybe I was not applying the same amount of force. Maybe it was landing on a different part of the table each time. So again, if it happens to be, our chi-square value happens to be below or at our critical value of 3.841, I would have accepted the null hypothesis and include the differences between those two values was really just due to chance. So at this point, you're going to do some practice on this. Now, we'll be doing practice in class with an activity with a bag of M&Ms. We'll be doing some practice problems. This is something that you are expected to know how to do. And this is one of the statistical analysis tools that you will be using if you go to college and take science classes in college. They will expect you to know how to do a chi-square test. So if you have any questions on this after we get practice on it in class, make sure you ask. This is like any other math that you're learning that's new to you. The way you learn it is by practicing and getting help if you need it. So please remember to ask for help. And that's it.